Thank you. So I'm the last session before the party, so we'll try to keep it moving along, hopefully. And, what I'm going to cover today is talk about Pacific Controls, who we are, what we do, and, we've got some, you've been hearing about these Internet of Things and devices that have been connected, etc., where we have actually done this for thousands of nodes and thousands of buildings. So the talk today is going to be about Pacific Controls, who we are. I'll talk a little bit about our Galaxy platform, which is a enterprise application that we've built, a few years ago. Now we're moving it using some WSO2 components, so we'll talk about that. And then I'll actually get into some reference projects, some projects that we've actually delivered already and have been working for the past several years. Okay, so we're not going to get into a lot of the technical details. I think you've seen that in the previous discussions, but if there's any questions, I'll be happy to take those and answer those. So Pacific Controls, is a company based in Dubai. That's a picture of our headquarters building. We're proud to say that this is Middle East first platinum-rated green building and 16th in the world. Pacific Controls is involved in delivering some of the world's largest end-to-end managed services projects, and we'll get into those. Some of the things that we provide are real-time business intelligence, managed services, enterprise software development that we use internally to manage some of these systems. Recently, we've also gotten into creating some M2M gateways that are pretty cost-effective, and we're actually moving from the pieces of hardware now down into what we call software-defined machines, and we'll talk a little bit about that. And some of our affiliations where we get a lot of our research done is through the University of Vienna. We have a Pacific Controls Cloud Computing Lab that's been established there for the past several years. A lot of the details of the enterprise application that we've created comes from reference designs that they produce for us. We also have a association with Lawrence Berkeley Lab here, not far from where we are here today, and that's where we do research on the energy-related stuff for buildings, because we are involved in a lot of buildings-related infrastructure, etc. These are some of the different verticals that we operate in. So pretty much anything to do with a smart city, where we have things like hospitality, transportation, critical infrastructure like airports, things like that. We're involved with, and we have actual projects that we've delivered in each one of those areas. We also, as part of this delivery and the amount of data that's coming in, you've been hearing about that, where it's been the explosion of billions of devices that are going to be connected. You need things like data centers, and Pacific Controls is also a proud owner of a Middle East largest data center, and I'll have a couple of slides about that as well that we can show you, where we deliver cloud-based solutions to many customers through the data center. Specifically within buildings, there are many subsystems, things like generators, switchgear, elevators, all of the stuff that makes the building comfortable, heating, ventilation, and air conditioning. We connect to all of those kinds of things that you don't see typically in a building that are hidden in ceilings and behind walls, etc. We take the data from there, bring it up to our Galaxy platform, run some analytics on it, provide useful information out of that data that we collect, and then save energy, provide comfort, etc. Okay, so we'll be talking about a lot of those things in a little more detail. Some of the services that are provided are things like 24/7 monitoring. So we have a command control center that's part of our headquarters building. We actually have a couple of those, 3 of those, in fact, and one here for the North American market in New Jersey. So we have an office in New Jersey and a command control center where we have operators and engineers that are staffing this, monitoring live data coming in from buildings that are connected, and then providing services like M&V, efficiency management, analytics, benchmarking, etc. All these things that are listed here. So this is a slide that I typically use to kind of describe how the information flows from the field devices, and we really don't care what that field device is as long as it has some kind of intelligence, and in some cases it may not have any intelligence, and we can provide some gateways or sensors to enable that information to us. So down at the bottom you see all these different kinds of devices that you might find in the world. Could be anything from, again, like a power generator, an air compressor, a meter, a security device, a CCTV camera, etc., what have you. And each one of those devices has their own specific protocols in a lot of cases. Okay, there are some protocols that are common now and are becoming standardized, like BACnet and LongWorks and things like that. But in a lot of cases, there's proprietary protocols in where the data is coming from these devices. We take those that piece of data, we normalize it, and we put it up into our cloud. So that's where you see the interoperability layer and the layer for the enterprise application. Once in the cloud, you see a lot of those little things that have been mentioned there, things like fault detection and diagnostics, carbon emissions reporting, energy analysis, dashboarding, M&V. All those services can then be provided to the end user through the cloud, and that's what Galaxy does. And on the top end, you have I've listed different stakeholders and what the benefits are that they will be getting out of that data that we're collecting. Okay? So it looks like kind of a busy slide, but it gives you an idea that any piece of information that's available to be connected, we are able to connect it to the cloud, bring it up into Galaxy, and then make some good use out of the data that it's providing. So we're in the business of providing services for what we call smart city, urban services. And traditionally, the way that these services have been provided are in vertical domains that are isolated. That's what you see represented here on the left-hand side. So this could be a building management domain. There could be a separate set of software for managing the transportation in the city, for example. Another one for healthcare. Another one for energy-related stuff. And what we've done is, through the use of this Galaxy application that we call Galaxy 2021, we've brought all these isolated stovepipe kind of applications onto the platform as virtual applications, virtual verticals. And this is a very important step in that now we can leverage all the core services that are provided by a single platform and then still keep all the domain-specific stuff in a virtual vertical and allow easy interaction between these verticals. Okay, that's what makes for a smart city. And we have a single platform that allows you to accomplish that easily. Okay, we'll talk a little bit more about this. What goes into Galaxy? What are the kinds of things that you need to do in general terms, so you have a sense for the scale and what's behind the scenes. So this is the Galaxy infrastructure. A lot of little boxes, a lot of things that have been discussed. This is based on the IoT reference architecture that Paul and others have shared. But there's a lot of detail behind each one of these little boxes, okay? We split Galaxy up into two kind of buckets. One is what we call the core services, things like licensing, user management, device configuration, things like that, that are part of the core part of Galaxy that any application would require. And then on the left-hand side, we have, what we call service stacks. So these could be for the individual verticals where we need to do something specific for a particular domain. Okay? One of the things that you see listed on there is called GBots. That's another one of innovations that Pacific Controls has developed or created, and that is the intelligent software agents that we can deploy to any device out there. And the real power of these agents comes from the fact that we can put them on any machine that hosts our one of the other innovations that we've done, which is what we call the software-defined machine. And the software-defined machine is a framework that we can download onto any controller that already exists on a lot of these intelligent devices nowadays. Whether it's a compressor, whether it's an electric vehicle, whether it's an elevator, all of these machines have some kind of a microprocessor that controls it. And we're able to download a little framework on top of that we call the software-defined machine that automatically knows how to connect to the bottom end and collect the data and then also send it up to the cloud into our Galaxy platform. Okay? So that's a major a step towards making this ubiquitous. Because one of the most difficult things right nowadays is that these machines already have a microprocessor that's controlling it, and in order to get data from there to the cloud, you have to add yet another controller or some kind of a gateway to it that makes it just financially not a feasible thing, and also causes a lot of issues when you're trying to put this into the machines at the factory. So this previous slide that I had was a pretty busy slide. That can be broken down into or simplified into this kind of a diagram. And I'll briefly mention, this is nothing new. You've all heard about it in the last couple of sessions here. We have sensors down at the bottom. They go through some kind of a gateway, whether it's a virtual gateway, meaning a software-defined machine, or a physical gateway. It communicates up to what we call the Galaxy framework. And within the Galaxy framework, we have things like domain mediators. So you may have many heterogeneous devices coming from a particular vertical. So let's say, transportation may have 5 different kinds of devices that are feeding data to you. You may want to have a domain mediator called, transportation mediator, which allows you to collect this data from many of these disparate devices, and then unifies that data up for Galaxy's consumption or the enterprise applications consumption. You also may have, once it comes in, you go into the real-time data service, where this could be time series data or any other kind of data. So you need some kind of a data service to manage that, whether you're going to be storing it into your database live, and this is a lot of data, so you would be getting into the big data kind of stuff, Cassandra and NoSQL, etc. And also to show it to a person in a live dashboard, you may have a stream of this data also going straight up to your application server, your web server, and then pushing it out to a dashboard that somebody may be monitoring live. Okay? You need some kind of tenant management. So because this is an enterprise application, you want to provide each tenant their own space, so you can control what kind of resources they're allowed to have in the cloud, based on your agreement with them, your SLAs, how that's going to be managed. So you need some kind of tenant management application in there. Application context management, again, that determines what kind of resources are going to be available to that application that you can configure based on your SLAs with your customer. And then up at the top is the important part, the service metering and the billing, so that you can properly account for how you're going to charge this customer for providing this service. So you have to have accurate ways to measure whether it's time-based or volume-based or what have you, whatever you've negotiated with your customer, how you're going to be able to bill them in the end. Okay? So this is kind of the infrastructure for Galaxy 2020, 2021, and then how it maps into WSO2, because we're at the WSO2 conference here. It shows our mapping of that on here, where we have we're making use of on the device cloud side for us, going through some message brokers and stuff, and the actual device protocol converters and things eventually end up into the CEP for monitoring short-lived time events that we can capture right as the data is coming in. And then we're also making use of the enterprise service bus. We're using WSO2's identity server, which we had to kind of customize a little bit because we have a very hierarchical kind of representation for our users and how we present them. So that's what we've used there. In addition to, all this is cloud ready, so runs on Stratus. Okay, so just to give you an idea about the 2021 concept architecture and how we use WSO2 components in there. I had a slide on device cloud, but we've talked enough about device cloud with Paul's talk and other things, but a few things that I'll mention is that for us, it's important that we have bidirectional communication because we have to manage the devices, obviously. We have to, and we're talking about billions of devices, so just to represent that is a huge challenge. Do you represent them in a tree? How do you navigate that tree? How do you, kind of keep track of where your devices are is a challenge, and we've got some solutions for that we've built into Galaxy 2021. Okay, so there are many kinds of devices. Some devices just start streaming data to you. Typically, in an automotive kind of environment, these devices just send data if the car moves 100 yards, or if the direction changes, or the speed changes, etc. And then for buildings, typically you have to go and ask for data. Okay, other than the events, which might be alarms that get pushed automatically, you may have to go from your enterprise side to go say, okay, tell me what your data is, etc. Or if somebody opens up a dashboard, at that instance you have to make a connection to it and start getting live data from this device. So in this device cloud is a key component that needs to be able to accommodate all those things that are mentioned on the right-hand side there. Okay. One of those things, and a question came up earlier about security, that is very, very important because, especially when you've got bidirectional communication, somebody can, you don't want somebody to be able to go in and all of a sudden change or shut down some equipment in 10,000 stores that you're monitoring, for example. Okay, so security is a very key component. There hasn't been some standard defined yet for this, where Pacific Controls is involved in kind of writing the rules for some of those things for security for this IoT space. So that's one other thing that we make use of our GBots in order to provide that security. So one of the concepts is that if you have a GBot installed on your device, even though it may be insecure, that makes it secure and it becomes the guardian of that device and how you manage it. Okay, and then from there, I just wanted to point out, this is a picture of our data center, because all this stuff, like I said, I'm not going to go into all the technical details of Galaxy, but how we support it. So one of the things that we have is this largest Tier 3 data center. This is also in Dubai, and we plan to have data centers or have hosting services similar to this on all 5 continents. We're connecting all the devices that are out there. Paul mentioned earlier that we eat our own dog food. Yeah, we do too. So this is all the systems that are just in a data center and our Galaxy platform is used to monitor that and control that data center. So we've got over 150,000 points just within one building, which is our data center that we're monitoring and controlling. And it's represented by all these little circles that you see: chilled water pumps, lighting, leak detection, you name it, whatever goes in there, we're controlling it, and we have an application specifically for data centers that we've customized or built within our Galaxy platform. So we talk a lot about managed services, and I just wanted to kind of level set everybody and tell you what we mean by that, so that as different people have different kind of concepts about that, and we'll use a building as an example or a machine from a building. So on the left-hand side is a city with some bunch of buildings, and you could be monitoring any single piece of equipment in there. On the right-hand side is our command control center, which kind of looks like this with big screens and live events happening and showing with subject matter experts sitting at these little stations that you see there. So we say machines talk, and we listen. So as the machines are communicating, we're listening to them. If there is an anomaly, that's detected, it will be sent over to our command control center, and we can take a number of actions based on that. With our subject matter expert could look at it and say, okay, this is something that I just need to monitor at the moment. So the first response could be, I'm just going to sit here and note it down. It's noted down in the application. It's logged, etc. We're just going to observe it and see if this needs to be further tracked later on. Another option is that we could fix the problem remotely. Okay, this is where the G-Box come in, and we can actually send something down to the machine, whatever that happens to be, whether it's a chiller, elevator, an escalator, some lighting system, you name it, whatever you have in the building. We could remotely send it some commands and fix that, and then obviously record it and tag it and report it to the owner. But if this is something that is not something that we can fix just by downloading something or with software, it needs to actually involve a technician or an engineer to send out to change a piece of equipment, then at least with the information that we have, we can send the technician with the appropriate parts. We can tell them exactly what they need, where they need to go, and what needs to happen when they get there. So the technician doesn't show up and then starts troubleshooting. The troubleshooting part has already been done. He just needs to go and take care of the problem, fix it. And then once the problem is fixed, because we're monitoring it, we will know, and then we can verify that the job has been completed and it's been fixed, and send a message out to the proper stakeholder that this is what's been done. Your machine was down and we fixed it, and it's all ready to go up and running. So this is what we call managed services, and this is what one of the things that we differentiate ourselves with is that we provide actual full managed services for all kinds of equipment in a city, any machine, and now we're involved with actually working with the manufacturers of these machines that go into these buildings, where they're embedding our technology right on their factory. So when a chiller leaves the factory, wherever it's made, it has our technology built in, so as soon as it's installed, it can know how to communicate to us. Okay, so that's another thing that a lot of the manufacturers are going towards. So to wrap the thing up, I'll just talk about a few of our projects that we've done. This is Dubai International Airport, Terminal 3, huge airport, one of the busiest airports in the world. And we've got Galaxy installed in there as a management platform that communicates to all the different systems that are in this critical asset like an airport. So from the flight displays that notify you where the plane is, to the air conditioning systems, to the the gates, the jet bridges that go out to the plane. So what happens is when a plane is about 60 kilometers from Dubai airport, it notifies the tower that this is whatever flight number it is, it's coming in, it's got X number of passengers on it. Our software takes over, notifies the jet bridge, the air conditioning needs to be turned on. It sends the messages to the overhead displays that where the people need to go. It puts the elevators at the right floor so when people are disembarking from the plane, they can get in and easily come in and get out of the airport, so they don't have to wait. And also, you can dispatch the fuel truck if it needs to go to that plane and refuel it. All that information is all tied in and running on the platform. And then most importantly, for the airport, we can generate an invoice for all the airport services within the hour and send it to the airline. This used to take a lot of time before, many weeks and months. Now it's done within the hour, and the airport can bill for all the services that it's providing. So this was done a few years ago. Here's a representation of all the different systems that we're tying together and managing at this location. Based on the success of that, now, Dubai being Dubai, it has to build the world's biggest, largest, whatever adjective you want to use. They're building the world's largest airport, about 140 square kilometers. This is a kind of a city. Just to put this in perspective, this is about the size of Washington, D.C. area. And there's all kinds of things. Not only is it an airport, but there's golf courses, there's hotels, there's other things there. And we are managing or been involved in controlling all the assets in there as well. Okay? So huge projects, critical projects that we're involved with. A lot of detail here, just some of the system architecture for how we control this. Won't go into a lot of details about this, but another, world's richest horse race is this another city where they is basically a little mini city within the city, and we're managing all the different assets here at this facility, Medan. So there's residential towers, hotels, commercial buildings, etc. All that make part of that. We manage and control that. But the biggest, I think, project in terms of scale is this Dubai Civil Defense Project, where we're connected to about 60,000 buildings in Dubai. So every building in Dubai is required, a commercial building is required to have it connected to our, the Civil Defense Command Control Center. This is analogous to the 911 system here in the U.S., for example, and it runs on our platform where we, if there's an alarm reported by any building, comes to our Command Control Center. We have a 2-minute SLA with the Civil Defense. Within 2 minutes, it has to be verified whether it's a real alarm or not. And then a fire truck has to be dispatched, or other, emergency responders have to be dispatched to the location. And when we dispatch the trucks also have a little tablet that we've installed in these vehicles that gives the drivers the instructions of where to go, and when you get there, what to do. The fire's on the 20th floor on this building. Here's the floor plan. This is how you're going to get up there. By the way, the emergency water tank on this building is empty, so you got to use the water from this location, etc. So all that information in real time is sent out to the emergency responders. Okay. So kind of just a general architecture. All the buildings, they communicate over cellular network. That's another big difference. So, and how we are connected. We're probably the largest consumers of SIM cards out in Dubai over there at the moment. And earlier we talked about MQTT and CoAP and things like that. one of the things that when you're dealing with cellular networks, you have to be careful of is how much data you can pump through there, and it has to be a very efficient protocol. In some of our studies that we've done, we're finding that even MQTT, is not suitable for some of these applications, and we have to come up with our old binary protocols to really compress this data, because there's a lot of data, and we don't want to be paying a lot of data charges to get this data collected from a lot of machines, especially when you're connecting billions of devices to the system. So that's another area that some work has to be done, and we're coming up with some protocols for that as well. Okay.
What kind of efficiencies are you trying to gain between MQ and your own protocol?
So it's just the amount of data, the actual packet size, and only transmit when you need to on a critical basis, and then embed as much information in every message that we do transmit, so that we don't have to have two messages to could have been conveyed in one message. So that's we found that if we use any of the standard technologies out there, they work fine if you're connected over VPNs or the internet over LANs and things like that. But going through cellular network, that can be a big hit.
Okay. Are you reducing the traffic by half or more? Do you have some numbers?
So a typical goal would be to be less than 1 meg of data per device per month.
1 mega data per month?
Yes. Yeah, we're shooting for about half that, but that's typically right now that's what we are dealing with. Otherwise, the charges for the data just go astronomical. Can't really make it work. Yeah, so that's a pretty tall order to do a mega data per month from a device. That's not 1 point. That could be up to 100 points in that device.
You guys should just have your own wireless network, right? That one.
Yeah.
I guess that's not practical. Yeah.
Just kind of a silly question. Yes. This is absolutely mind-blowing, by the way, and thank you for the presentation. I understood about 10% of it, but it's really, really impressive. I'm just wondering, it's just incredibly mind-blowing about when I consider the amount of data that you guys are dealing with, and I'm wondering to what extent you're leveraging that data to do things like big data predictive analytics, because it seems like you're in an incredible position to be able to make predictions about what could happen, based on all these different events. And I'm wondering if that's part of your vision, or maybe you're
no, that is the vision. That is the vision. Pacific Controls prides itself in being the company to make use of this data and actually monetize it. Okay, and if you Google in the U.S., for example, IntelliCommand, which is an offering by Jones Lang LaSalle, a facility management firm here, one of the largest, they use our system to manage their buildings. And we do exactly that. We do a lot of fault detection diagnostics for them. We have a whole library of analytics that we run, so we can detect a simple example. For example, if there's a leaky valve, if you have a hot water system and you're feeding some water into a radiator and you want to know if the valve is leaking, we have algorithms that can tell us that, and we can proactively inform and send a work order to the on-site workforce or to JLL's mobile engineering workforce to go and fix that. So that's just one example of that, and we have a whole list in our library, and we're continuously developing new techniques and new algorithms for these predictive analytics. And we make use of, like I mentioned earlier, Lawrence Berkeley Labs to do some research on that for us as well. Okay. Any other?
Did you use any Hadoop or any big data kind of, because this much amount of data, I don't think you can scale up with RDBMS kind of.
Oh no, yeah, there's no, it's not RDBMS. We do use Cassandra and Hadoop and Storm, and yeah, there's a lot of detail that goes. Yeah.
What is your data traffic split between the mobile signaling and land signaling?
I'm sorry, say it again?
What's your traffic split between sending things over the air over the 4G networks compared to sending things over the land?
So the majority of our traffic actually does go over the 4G or 3G or 2G, depending on where we are. It's over cellular networks. One of the issues that you run into typically is the on-site IT folks, and they say you're not going to connect this building. You're not going to have any connection to my building, and if it's going to touch my network. So a lot of times we end up installing a cellular modem there and then feed the data that way, where we don't have to work with the IT folks or not have them involved because of their paranoia about it somehow affecting them. Okay. So we work with the facility managers, and they can get the data out over cellular. There are cases where we connect a whole campus, for example, and some universities or some large corporate customers where they already have a wide area network connecting their buildings worldwide, and we would then have one VPN connection from there back to us. So depending on the customer, we have both scenarios, but majority of our data comes in over cellular networks.
One biggest problem in this, what we earlier we did one project where packet loss is the biggest problem that we see when we do over the air. Right?
So you have to build all that in. So we have mechanisms on the devices that we install at the edge that know how to, that know that it hasn't been and it starts collecting. So depending on our SLAs, it could collect data up to a week, a month, whatever. And we have different variations of the devices that we can install at the edge and take care of that. And when the connection is restored, we can dump all that data back in. Okay? All right, thank you.